Okay, so now compare this term with our received term. Okay, so here we get some terms. No, here we get some terms. Here we get some terms. So we have a constant. So what is this? This should be this value. No, this should be this value. Okay, any value. Okay, so this is the coefficients. This is the coefficients. Fourier series coefficients. Okay, so this will be the coefficient. Okay, and this will be your exponential terms. This will be your exponential terms. Okay, so here also the exponential terms is there, but it is a constant. It has a value. Okay, it has a value. If you can use MATLAB and you type it here, you type this in the command window and get the value, you will get the value. So here you will get the complex value actually. Okay, this will be like a plus I y value, a plus iv value. This will be a complex value. So it is a coefficient. Okay, it is the coefficient. Okay, actually you can find this value easily. Okay, you can use the Euler formula. So if you use the Euler formula, it is cos phi by 2 plus j sin by phi 2. So you know that j phi by 2 is 1, cos phi by 2 is 0. So you will get j1. Okay, so this value is 1j actually. If you find, you please use the MATLAB and try to find the value here, you will get 1j. Okay. So this is a constant. Okay, and this is the exponential terms, because you can't get the value for this exponential term because there is a variable. Okay, there is a variable. This t is a variable. Okay, so actually this term is identical to this term. Okay, now you please compare this. Now you want to find this value. What is this value? A1, A2, or A3? You have to find this k value. So this is the kth value. No, k value. K value means the harmonic number. Okay, so this is the k value, that is harmonic number. Okay, because these are we called harmonics. These we called harmonics. Okay, or frequency component. Actually, these are frequency component, basic frequency component. Okay. Okay, so please compare this one and this one. So you have j here, j here. Okay, and you have omega naught here. So omega naught here is 105, and you have t here also. Okay, so what is the k value for this? K value for this. What is this k value for this? Actually, it is 1, no? Okay, so for this term, k is equal to 1. Is this okay? Is this okay? You got this? Okay, thank you. Okay, so if anyone is still couldn't understand this, okay, if anyone is there, maybe some of the still may have doubts with this. Okay, so what you have to do is you have to work. Okay, that is the only thing you should do. You have to work, and then you will be an expert. Okay, then you can understand this concept. Okay. Okay, so you have to work by yourself. Okay, you have to do the examples by yourself. Okay, otherwise this concept will not, you can't catch this concept very well. Okay. Okay, okay, now tell me, what is the k value here? Please tell me that one. What is the k value for this one? Okay, so for this term, the k is equal to 1. Okay, I will write that term here again, because now it's not very clear now. Okay, so we have xp. Okay, and as I can remember, we have half e to the power j5 by 2. Okay, and we have e j 105 t. Okay, so this is omega naught. So this is the omega naught. This is the omega naught plus half. Okay, plus half e j pi by 2 minus and e minus j 105 t. Okay, and again this will be the omega naught. Okay, so this will be your coefficients actually. This will be your coefficients. So you know that here the k is equal to 1 for this term, k is equal to 1. Okay, so this should be a1, no? So this should be a1. So you have a1 is equal to half e to the power j 5 by 2. Okay, so if you use the Euler formula, you can get the value here. E j 5 by 2 is equal to 1j. So here you will get half j. Okay, so this is your a1. Okay, this is your a1. Okay, if you can't go to this step, it is okay, no issue. Okay, no issue. You can stop your calculation here. Okay, okay. So here you will have half j. This is the a1. Okay. Now this term, this is another harmony. Okay. So here this one also another harmony. Okay. So you have to find this k value here. Okay. So tell me what is the k value for this term? Tell me what is the k value for this term? K means harmonic number. What is the harmonic number for this term? Please tell me. Now we are running out of time very quickly. Okay, so please tell me what is the value, k value. At a glance, you can tell it, okay? By looking at it, you can tell it. Please tell me someone. What is the k value? Yes, very good, okay? I got one answer actually. I got one answer. Please someone, please feedback another one. I got one answer. Please another one. So Kisara, Afras. So do you have any answer? If it is wrong, it is okay, okay? Please tell me. I think at a glance you should be able to you should be able to um, so you can compare it with one with this term, maybe with maybe a term with this. Okay, so what is the k here? So here you have omega, so this whole term is omega, and you have t and you have j. Okay, so this will be a constant. Okay, this will be a constant. Okay, so actually if you simplify this, you will get minus half j for this value. So it is a constant. Okay, it is a complex value. So what is the k? So this is actually a this is the complex exponential term. Okay. So you have here j omega naught and you have t. Okay. What is the k value? Okay. If I say that k is equal to 1, is it okay? Are you agree with me? I say that k is equal to 1. Are you agree with me? Okay. Yeah. Oh, I know that you answer, okay, because you have given the correct answer. Okay. And so again, look at again think. Okay. So this term, you can see that this term is minus j 105t. Okay. So if you want this, okay, if you want, so if you write this in terms of k and omega naught, it will look like this, no? J k omega naught t. Okay. So this term will be look like this. There are some k value. There should be a k value here for this term. Okay. So please compare this with this kind of term. You can compare this one and this one, and you can find the k here. Okay. So if you compare this omega naught is 105 t, and 105 is there, t there, j there. Okay. So what is the k? What is that? Afras, what do you think? Okay, is it okay? Please look at it carefully. If you think this k is equal to 1, so it is just like this, e j k omega naught t. Okay. So if you get k is equal to 1, okay, k is equal to 1. So this will be e j 105 t. But here that is not equal, no? So if you think k is equal to 1, okay, so that term will be e j 105t. Okay. So in this term, if you consider k is equal to 1, okay, if you consider k is equal to 1, this term will look like e j 105t. This one and this one equal. This one and this one equal. No. What is the difference? It is not equal. This term and this term will is not equal. What is there? What is there? What about this minus sign? Anyway, thank you for your effort. Okay. So what about this minus sign? Is this equal? Yeah. Yeah, maybe. Okay. So what is actually the k value here? What is the k value here? So this is not k, no? K is not equal to 1. What is the k value? K is equal to minus 1, no? In this case. Okay. So I will explain it again. I think other student didn't get it. Okay. So I will explain it again. Okay. So please see some videos. Okay. So you can get this. Okay. If you can't understand my fashion, okay, you can refer. There are many YouTube's videos, and there are many notes actually. Okay, so if you have you can go through your textbook. You can go through your notes. Okay, so anyway, you have to get this. Okay, so I will tell it again. Okay, so here we have two terms. Okay, here we have two terms. Okay, now our aim is to find the which harmonic, the number of harmonic, not number of harmonic. The number of harmonics is two, no? So we have two harmonics. So number of harmonic is two. Okay, there are two harmonics. Okay, now we know we should know the harmonic number. Okay, we should know the harmonic number. Okay, we should know the harmonic number. Okay, so I will another time one more time I will explain this. Okay, because without knowing this we can't go further. Okay, so here we have j 150 half e minus j5 by 2. Okay, so you know that these are constant. Okay, these are constant. Okay, so these are constant. Okay, these are constant. Okay, these are constant. Okay, so this will be our exponential terms, and here this will be our exponential terms. So here it is minus. Okay, minus j 150. Okay, so if you have this signal xt, okay, xt, and if you write this in terms of Fourier series coefficients, you will have this kind of expression: a minus 1 e to the power j minus 1 omega naught t. So this is the k value, the harmonic value. Okay, and you will have a 0 e to the power 0. Okay, so e to the power 0 will cancel out. Okay, okay, plus a1 e to the power j1 omega naught t plus a2 e to the power j2 omega naught t, so on. You will have some value. Okay, so you will have some value. Okay, like this, and also in this way. Okay, now if you compare this and this one, so this will be our default Fourier series representation. Okay, so this is the generalized, the common way. Okay, so this is the generalized series. Okay, now we have a xt. Okay, and you can see that we have two terms here. Okay, this is first term, and this will be our second term. Okay, so we will have only two terms, no, only two terms from this series. Okay, so now you have to find what are the terms. Okay, what are the terms? In other words, you have to find what are the harmonic, what are the harmonics. Okay, what are the harmonics? Harmonic means the k value. You need to find the k value. Okay, this, because this k will indicate you the harmonic number. Okay, harmonic number. So if you find the k value, okay, if you find the k value, so these are k values. Okay, this is the 0th harmonic, this is first harmonic, this is second harmonic, this is the minus first harmonic. Okay, and you will have this kind of kth harmonic like this. Okay, okay, so this k is the harmonic number. You have to find the harmonic number. In other words, here you have to find the k value. That is what you have to find. Okay, so how you can find it? How you can find it? So if you have omega naught here, so if you can find the omega naught, okay, so you have the omega naught here. Okay, so you have j omega naught t, and there should be k value also. Okay, there should be k value also. Okay, so you can see that ej 105t. So this will be omega naught. Okay, so there is no any other values, no. So k should be equal to 1, because if you multiply this by 1, not change happen. Okay, so k should be plus 1. So here for this term, k is equal to plus 1. Okay, so that means the first harmonic. So here we have first harmonic, and that is equal to a1 is equal to half e to the power j 5 by 2. Okay, so this is the first term. So k is equal to 1 here. Okay, now we have find one terms. Okay, now we are going to find the second terms. Okay, so what is this? Okay, so this will be the coefficients. It is a constant value, constant complex value. It will be the coefficients. So this will be our exponential terms like this. Okay, so now we want to find the k value here. Okay, so k value, we can write the k value like this. Okay, e j k omega naught t. Okay, so if I write this here, okay, if I write this here, so this should be e j k omega naught t. Okay, so omega naught you have 105. Okay, so here -1 is there, so you need to find the k value. Okay, so if I write like this, j k -1 105 t, that is omega naught t. Okay, so again this is equal to e to the power minus j 105 t, no? Okay, for this term. Okay, so what is the k value here? It should be -1. Okay, so it should be -1. The k value here should be -1. So here k is equal to -1. Correct? Okay, so I have a -1 equal to half e to the power minus j 5 by 2. Correct? Okay, so you have a1 and a -1. Okay, you have a1 and a -1. Okay, now we will find the other one also. Okay, so try to understand this from this one maybe. Okay, so this is more simple. Okay, so we have another signal that is yt. Okay, so we have another signal. We have another signal that is yt is equal to sine 205t. Correct? That is the signal, no? Sine 205t. Okay. Now please write this in terms of complex exponential terms using the Euler formula. Okay, try by yourself how to find this, how to write this by Euler formula. So I will do this. Okay, but you should do this by yourself also. Okay, because the time is now the time is running very fast. Okay, so I will I will do this. Okay, so you can use the Euler formula for this one also. Okay, so you know that. So here I will go here again. Okay, so you can see that these two terms. Okay, so if you reduce, if you subtract 2 by 1, 2 by 1, what you will get? Okay, so this cos term and cos term will cancel out. Cos theta minus cos theta, you will cancel out. So here you have j sin theta minus j sin theta. Okay, so here you have j sin theta minus j sin theta. Correct? So here you have e j theta minus e minus j theta, and here you have j sin theta minus j sin theta, like this. Okay, so this minus will be plus. Okay, and you have j sin theta plus j sin theta, that means 2j sin theta. Okay, so you have 2j sin theta. So here is j theta minus e minus j theta. Okay, so what is sine theta? Sine theta is equal to here. So you have to find the sine theta, you have to divide these two terms by 2j, because here you have 2j. Okay, so sine terms I have 1 by 2j e to the power j theta minus 1 by 2j e to the power minus j theta. Okay, so sine terms I can write like this. Okay, so I will write it. Okay, so I will write it. Okay, so I have half j. So theta is this now. So here the theta is equal to this term. Okay, so I have e to the power j 250 minus half j e to the power j minus j 250. Okay, so this is my terms. Okay, so here I have a coefficients, here also I have a coefficients, here also I have a coefficients, and this will be my complex term. Okay, so if you consider this one, the omega naught is equal to 205. Okay, so omega naught is equal to 205. Okay, so here also omega naught is also 205. Okay, so this will be omega naught, and also this will be omega naught. Okay, so if I write these two terms in terms of omega naught, okay, so I have like this j omega naught t. Okay, this omega naught we have already know. Okay, 205 plus sorry, minus half j e to the power minus j omega naught t. Okay, here also omega naught t is equal to 205. Okay, so if you compare with this the Fourier coefficients, okay, so these terms will equal to, okay, will be equal to this kind of terms e j k omega naught t. Okay, so you have j omega naught t, j omega naught is 205t. Okay, so whole terms is there. So here k, what is the k here for this value? The k should be 1. Okay, so for these terms k should be 1. Okay, k should be 1. That means that is the sorry, for this, let's take for this signal, the coefficients are bk. Okay, so I have b1 here, so I take this coefficients as bk. Okay, xt Fourier series coefficients I take as ak, so I have a value a1 and a minus 1. So here xt, if I get the yt Fourier series of yt, so let's say that it is bk, Fourier coefficients are bk. So I have b1 here because k is equal to 1. b1, this is the first harmony. Okay, so the coefficients is 2j. Okay, and what is this? If you consider one, if you compare it with jk omega naught t. Okay, so here you have j, you have omega naught, you have t. So what is k? So for these terms, the minus should not be there. Okay, so you can get this minus and you can put it like this, minus 1. Okay, so you can write this term, okay, like this, e j minus 1 omega naught t. Okay, so this omega naught is 205. Okay, this omega naught is 205. So the k is minus 1. Okay, so this will be the minus 1 coefficient. So it will be b minus 1. It will be minus, so because this minus is there. Okay, so it will be minus 2j. Okay, so this is b1 and b minus 1. Okay, I hope you get it. If not, please go through the lectures and try to understand this. Okay, okay, now we have find the ak value. Okay, we have found the ak value, the harmonic for xt, and we have found the bk value, harmonic coefficients for yt. Okay, Now say that we are given this kind of signal. Okay, we are given this kind of signal. Zt is equal to 3xt plus 5yt. So if you get the Zt uh, Fourier series of Zt, it will be, let's say that Ck. Okay, so using this result, so here you have a1, a minus 1, okay, for xt, and b1, b minus 1 for yt. Okay, so can you find Ck? So you no need to go through the Euler formula and apply this. Okay, so here you can use the linearity property. Okay, so can you tell me, use linearity property and try to find the Ck value? Okay, please try to get the idea. Okay, I will do it. Okay, so this is the linearity property. We already seen it. This is the linearity property. So this will be the linearity property. If you have xt, Fourier series ak, coefficients ak. If you have yt, Fourier coefficients bk. Okay, and if you get a plus xt plus b into yt, this kind of signal, the Fourier coefficients also will multiplied by the same weight. Okay, and those should be added. Okay. Okay, so this is the linearity property, so you can apply it here. If I apply it here, okay, if I apply it here, so you have Ck. Okay, so Ck is equal to a ak plus b bk. Okay, okay, so this you know. Okay, so now you know what is this a and what is this b. So here the a is equal to 3 and b is equal to 5. Okay, so you can say that Ck is equal to 3 ak plus 5. Okay, so you have a minus a plus 1, a minus 1, b plus 1, b minus 1. Okay, so let's take C1. Okay, if you find the C1, C1 is equal to 3 A1 plus 5 B1. Okay, so what is the C1? 3 A1, 5 B1. So you have already find this A1 and B1 value. Okay, so what is B1? B1 is half 1 by 2J, and what is A1? Okay, a1 is this half e to the power j5 by 2. Okay, and if you so here you can use this one directly. Okay, no issue. And if you can also, you can further simplify this. So you will get half j. Okay, and for this you will get minus half j. Okay, so you can get this value, or you can get this value, no issue. So you know you can get the a1. Okay, so here a1 is I will get the uh, the original one. Okay, so I have half e to the power j5 by 2. Okay, multiplied by 3, because 3a1, so this will be the a1, and the b1 will be j by 2, no, sorry, 1 by 2j, 1 by 2j. Then I can write this 1 by 2j multiplied by 5. Okay, so this will be my C1. Okay, and if you want to find the C minus, okay, if you want to find the C minus, then you will have 3, okay, a minus 1, 5, b minus 1. Okay, so already you have find this a minus 1 and b minus 1. So you will have 3 a minus 1, as I can remember, it is half e to the power minus j5 by 2. Okay, you can please compare it with the answer. Okay, so I think this one plus 5 b minus 1 is minus 1 by 2j. Okay, so this will be your c minus 1. Okay, no need to simplify up to this level. It is okay, you can get the full mark. Okay, so if you can further simplify this, you can simplify it. Okay, if you couldn't, you can only find the coefficients like this. No need to simplify this. Okay, so that is the use of linearity property. Okay, so if you have any signal added together, okay, then you can use in the linear property. If you know the if you know the coefficients separately for those two signals, okay, you can find the resultant signal Fourier series coefficients using the linearity property quickly. Okay, so that is that. Okay, so we will go to the other property. Okay, that is time shifting property. Time shifting property. So I think already we have learned the time shifting, that is under time transformation. Okay, time transformation. Okay, so if you are given xt, okay, and if you get the Fourier series, let's say that ak, okay, then if you are given xt minus t naught, that means time shifted signal. Okay, so this is the time shifted signal. So Fourier series coefficients will be, I can't remember, we have to check. So here time shifting. Okay, so xt minus t naught, you will get this ak e to the power minus jk omega naught t naught. Yeah, yeah. ak e to the power minus jk omega naught t naught. So this will be the answer. Okay, so you will get some exam related question. Okay, you will get some question related with this properties, with these three properties mainly. Okay, so what is the ak? So here the coefficients, let's say that it is bk or something, so that is equal to e to the power, I can't remember that one, e to the power minus jk omega naught t, e to the power minus jk omega naught t multiplied by ak. Correct? Okay. So to illustrate this time shifting property, I will get I will get the example quickly. Okay, so let's say that you have the yt. Okay, that is sine 205t. Okay, so you already know the a1. So let's say that the Fourier coefficients for this signal is a1 and a minus 1. Okay, so you already find this. So for this one, you will get half 2j, and a minus 1, you will get minus half 2j. Okay, so using the time shifting property, using time shifting property, using time shifting property, I'm going to ask you to find the coefficients of y t minus 5. Let's say that, yeah, t minus 5. T minus 5. Okay, so find the Fourier transform for this signal y t minus 5. Can you find the Fourier transform using the using this time shifting property? So try to calculate quickly. I think you can do it. Very simple. Okay. you can use this formula. You can use this formula, and what you have to do is you have to substitute the relevant value here. Okay, you have to substitute the relevant value. So you have the k value, you have the omega naught value. Okay, and you have this is t naught. Okay, and you have t naught value. So t naught, this one 5 is the t naught. Okay, so all the values are there. What you have to do, you can simply substitute. Okay, so 1 minute, tell me the answer. It is very straightforward. Okay, I will write it here. I just there is no any simplification. I just write. Okay, so please compare this one and this one. Please compare this one and this one. So here x t minus t naught. Here I give y t minus 5. So this will be your t naught. Okay, t naught is equal to 5. Okay, so uh, here I have given the t omega naught. So what is the omega naught? This one. Omega naught is 205. Okay. Omega naught is 205. Okay. And you have two values. Okay. One is k equal 1. Another is k equal minus 1. Okay. So you can write the two coefficients very simple. Okay. So I will write the two coefficients. Okay. I will use this one. Okay, so you know that I will write it again here. Omega naught is equal to 205. Okay, and the t naught is equal to 5 times shifting. Okay, so this is the shifted time, so it is equal to 5. Okay, and we have already have the coefficients, these coefficients for yt. Okay, so these coefficients are a1 and a minus 1. Okay, so here k is 1 and here k is minus 1. Okay, so I am going to write the coefficients for this y t minus 5 for this signal. Okay, let's say if I get the Fourier series, let's say the coefficients are bk. Okay, so there are two k value. K is equal to 1 and k is equal to minus 1. So I should have two terms also, no, two coefficients, b1 and also b minus 1. Okay, so if I write the b1, okay, so you can use this one. So here the k is equal to 1. So I have e minus j k is equal to 1. Okay, so what is omega naught? Omega naught is 205. So you have 205, okay, multiplied by t naught. T naught is 5. So you have to multiply this by 5. Okay. So you can see that it is e to the power j 205 5. Okay. Okay. So this is a constant. No, there is no any t value. So this is a constant. And it should be multiplied by ak. So here k is 1. That means you have to multiply it by this a1. So you have 1, 2, 3. Okay. So this is the b1. In the same manner, you can write the b minus 1 also. So you have e to the power minus j. Okay, so here k is equal to minus 1. K is equal to minus 1, and omega naught is equal to 205, and t naught, so this is t naught. Okay, t naught is equal to 5. Okay, so this is also a constant, and it should be multiplied by a minus 1. So what is a minus 1? Minus half minus 1 by 2j. So you have minus 1 by 2j. Okay. So this is the other answer. So you can write, you can find b1 and b minus 1. Okay. So if you couldn't understand, please try to go through this and try to understand. Okay. So if you have any problem, you can ask me. Okay. If you ask in the problem, I always there to help you. Okay, no issue. If you are asking some problem, actually uh, I like it very much. Okay, you can send me a mail, you can call me, and you can send me some WhatsApp message or anything. Okay, then I can respond. Okay, so that is the time shifting property, and that is the use of the time shifting property. Okay, so quickly see the time reversal property also. Time reversal property. So this actually this proof are very simple. Okay, to prove these properties, uh, simply we can do this. Okay, and the proof also there in your textbook. Okay, but I am not going to do the proof here. Okay, I just want to I just want you know how to apply them. Okay, if you can apply these properties for your analysis, that is okay. Okay, when we are analyzing a system, okay, especially linear time invariant system, okay, still we are not discussing about the system. Okay, actually I hope to come to the system level. Okay, but I just forget it because uh, uh, we are not tally. Okay, I couldn't get uh, this 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 class up to intended level. Okay, that is the problem. It may be my issue. Okay, it may be my issue. uh, it may be your issue also. Okay, I don't know. So that is why I just after this, after properties, we will stop the theory parts, then we can do some example. Okay, so I'm going to do the time reversal property. Okay, so time reversal also, you know what is time reversal, that is time reflection. Okay, so here if you have xt signal, and if you get the Fourier series, let's say that Fourier series coefficients are ak. Okay, and if you get the time reversal signal like this x minus t, so this will be the time reversed signal. Okay, and if you get the Fourier series coefficients, let's say that these are bk. Okay, bk is equal to a minus k. Very simple, a minus k. Okay, a minus k. Okay, am I right? Let's check it again. Time reversal, a minus k. Okay, so what is it mean? Okay, let's take example. Okay, I will get the same example. Okay, sine. So I have a signal xt sine 205t. Okay, so this is my xt. This is xt or yt. Any signal you can. This letter is only to represent the signal. Okay, so xt I have sine 205t. Okay, and the ak for this signal. Okay, we have a1 and a minus 1. A1 is, okay, a1 is a1 is this a1. So we have already find that. So a1 is half j. No, yes, a1 is half. Sorry, yeah, half j, not half j, 1 by 2j, and a minus 1 is minus 1 by 2j. Okay, so a1 is 1 by 2j. A minus 1 is equal to 1 by 2j, that is minus. Okay, so can you find the Fourier series of x minus t? Fourier series, let's say that is bk, and can you find the bk? Please do it. Please do it by yourself. Please take 5 minutes. Not 5 minutes. It is just you can see this and you can say what are the b values and what are the what is the value. Okay, so you can see that bk is equal to a minus k. So try to get the understand a minus k. bk is under bk is equal to a minus k. Okay, tell me the values. Yeah. Okay. So I think one answer is correct, but uh, yeah. So anyway, thank you for your answers. Okay. 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 So here, I think you have done a mistake. Okay, you have done a little mistake. So I think now you can understand this. Okay, try to understand. So here you can see that bk is equal to a minus k. Okay, that is not equal to minus ak. Okay, that is not equal to a minus k. Okay, so you have to understand the difference between these two terms. Okay, so here it is a minus k. Okay, not minus ak. Okay, so that means, okay, let's say that we have a1, a2, a3, a4 terms. Okay, so we have some value here. Okay, we have some value here. Okay, and for this time reverse signal x minus t, we will have the minus value. We will have the minus value. So here, for example, we will have b. So b. So here we will have the minus. So this coefficients will be reversed. Okay. So here we have, for this b value, we have a minus 1, a minus 3, a minus 2, a minus 4. Okay. So these are the, sorry, not a. Okay. So we will have b minus 1, okay, b minus 2, b minus 3, b minus 4. Okay. So what is b minus 1? B minus 1 is equal to a minus k. Okay. A minus k. So that means the k is equal to minus 1. So a is equal to minus 1. K is equal to minus 1 again. So minus minus 1, that means a1. Okay. So here a1. B minus 1 is equal to a1. Correct? Did you get this? Okay. B minus 1 correct is equal to a1. Okay. And in same manner, okay, so b minus 2 should be equal to a minus minus 2. Okay. It should be equal to a minus minus 2 because it is minus k. Bk is equal to minus k. So if you have b minus k, a should be minus minus k. That means ak. Okay. So here b minus k is there. A minus minus k, that means ak. Minus minus, you will get plus. Okay. So it will be ak. Okay. Same here. B minus 2 is equal to a minus minus 2. That means a2. Okay. Plus a2. So b minus 2 is equal to a2. And b minus 3 is equal to a minus minus 3. That means a3. B minus 4 is equal to a minus minus 4. That means a3. Okay. So these are the value. B minus 2, b minus 1, minus 2, minus 3, minus 4. So you will have the k reversed coefficients. K is reversed, not the value. The not value is multiplied by minus value. Only this k is multiplied. Okay. So actually, what are the bk here? What are the k here? So you can see that. So for this signal, bk should be equal to a minus k. A minus k. Okay. Bk should be equal to a minus k. So what are the k value available? So you can see that we have a1 and a minus 1. So this one is a1. Okay. This is a1. Okay. So here we have a1. That means we should have b minus 1. Correct? Because b minus 1 means a minus 1, 1. The k value are interchanged. Okay. So b minus 1. Here we have b minus 1. B minus 1 is equal to a1 and it should be 1 by 2j. Okay. So we have b minus 1 here. And if you have b minus, so here you have a minus 1. Okay. A minus 1. That means you should have b1. Okay. Because b1, 1, k is 1. So you have a minus k, minus 1. So you will have a minus 1 here. Okay. So b1, a minus 1. And what is the a minus 1? It should be 1 by 2j. Okay. So maybe still you can't understand this. Okay. So it is very simple actually. Okay. It is very simple. So what we should know is, okay, if we have some value, let's say a minus 1, a minus 2, a minus 3, a 4, a 5, a 0, so on. We have some value. Okay. And we the time reverse signal. Okay. So this is for xt. Okay. Any signal. Okay. And if we consider the time reverse signal x minus t, okay, so we have all these k's are inverted, not inverted, the reversed. K should be reversed. Okay. That means it is multiplied by minus. Okay. So for corresponding to this a1, we will have b1. Okay. And b1 will be equal to a minus 1, the value for this a minus 1. And corresponding to a minus 2, we will have b2, and it is equal to a minus 2. Corresponding to a3, we will have b3, a minus 3, we will have b3, and that is equal, that will be equal to a minus 3. Okay, and corresponding to a4, we will have what? B minus 4, and that is equal to a4. Corresponding to a5, we will have b minus 5. That means that is equal to a5. Okay, and corresponding to a naught, we will have b naught, because for naught, 0, 1 and minus not relevant, no? 1 no minus not relevant, so b 0, and here it is equal to a 0. Okay, so you can see that for xt we have kth harmonics. Okay, xt we have uh, the harmonics number, here harmonics number are -1, -2, -3, 4, 5, 6. So these are the harmonics number. And if you consider x minus t, what are the harmonics we have? We will have 1, 2, 3, -4, -5, 0, and this will be 0. Okay, so these are the harmonics. The harmonics are inverted. Harmonics are inverted. And this is not inverted, reversed. Okay, so this reversed harmonic is equal the corresponding harmonics. Okay, so these are equal. Okay, so quickly I will do another example. Okay, so let's say that we will have yt. Okay, another signal yt that is equal to 2 cos. Okay, 2 cos 50t, 2 cos 5t. Okay, so please use the Euler formula and try to find the correspondence exponential terms. Okay, and you will get a1, you will get two terms, two coefficients. You will get a1 and b1. Okay, actually you should be able to do this kind of question by your mind. Okay, no need to use a paper. Very simple. You can do it by your mind. Okay, uh, please please do this. Okay, try to solve the question by yourself. Okay, then you can do it. Now if I ask you to add 2 plus 5, you no need to put you no need to use fingers. So no, you can do it by your mind. It is 7. Okay, if you have 2 by 6, if I ask you to find 2 by 6, then also you can do it. You can say it is 12. Okay, so you are not using any you are not going to calculate it. You can simply say it. Okay, so how you get this ability? How you get this ability? Because you have done this many times. Okay, you have done this many times, and now you are familiar with this. Okay, now you can remember, you know what how to get this quickly. Okay, so if you do this kind of questions very often, then definitely you will also be able to do not a very complex one. Okay, but simple one by yourself. Okay, by your mind. Okay, so if I write this, I will get 2 half. So I will get here 2 half to the power 5t. Okay, so I will get 2 by half only. Okay, and that is a1, and I will get a minus 1. A minus 1 is also 2 by half. Okay, so I will get these two. Okay, so I have a1 1, a1 is equal to 1, a minus 1 also equal to 1. Okay, a minus 1 also equal to 1. Okay, correct? I'm not sure. Let's take it. Okay, I think this kind of question we can't do by our mind. No? So if I write this in terms of Euler formula, it will be J5T, okay, 2 by half J5T plus 25 J minus J5T. Okay, so half will cancel out. So this will be the coefficient. So A1 will be 1, A minus 1 will be minus 1. Correct, no? Okay, A1 will be 1, A minus will be 1. Okay, so if I ask you to find A minus T, what is the answer? The Fourier coefficients of A minus T, time reverse signal. BK, let's say that BK. So what is the what is the uh, what is the value? BK value in the same manner. So you have A1 and B minus 1. Okay, so you have a reverse signal. Okay, reverse K. Okay, so instead of A1, you will have B minus 1. Okay, and that B minus 1 is equal to 1. Okay, and instead of A minus 1, okay, you will have B plus 1, and that B plus 1 is also equal to 1. Okay, okay, okay. Okay, let's say that we have so we have find we have given a signal xt. Okay, we have given a signal xt. Okay, we have given a signal xt, and uh, and if we get the Fourier series, okay, so Fourier series coefficients are a1, a2, and a0. Okay, a1 is equal to half, a2 is equal to minus j, a naught is equal to 3. Okay, so a1 is equal to half, a2 is equal to minus j, a naught is equal to 3. Okay, so if you get the time reverse signal x minus t, okay, so tell me what are the Fourier series coefficients bk and what is the value? Can you tell me? Okay, so here we have a1, a2, a naught. Okay, so corresponding will be b minus 1. Here it will be b minus 2. Here this will be b naught. Okay, so b minus 1 is equal to a1, that is half. Okay, so this is a one answer, and b minus 2 is equal to a2, that is minus j. Okay, so this is another equation, and b another coefficients b minus 2, and a3 is equal to a naught is equal to b naught, and it is 3. Okay, so you can see that if you have a1, a2, a naught, that means 1, 2, 0 harmonics for the time reverse signal. For this is xt. Okay, for the time reverse signal you will have b minus 1, b minus 2, b0. That means you will have minus 1, minus 2, 0. Okay, okay, so these are the harmonics. So the harmonics number will be reversed. Okay, so that is the idea. Okay, so we will stop here. Okay, we will stop here, and if you have any question you can ask. Okay, and I